Okay, now we're going to talk about the different types of variation. So, we have direct variation, inverse variation, and joint variation. Direct variation is of the form, and remember, this is very generic, okay? So it doesn't have to be y and x. It doesn't have to be k either. K is what we call a constant of variation or a constant of proportionality. Those two things, in this case, mean the same thing. K will not equal 0. If k equals 0, then it's not a variation problem. But again, it doesn't have to be k. K is just some constant. So, direct variation is of this form, where we would have y equals kx. The way we interpret this is we would say y varies directly as x, or y is directly proportional to x. Notice that this is the same as a line. So this you can think of, your y equals mx plus b, except for b in this case would be 0, and we're using k instead of m. Otherwise, it's the same thing, except for the context would be a variation equation. Inverse variation is of the form y equals k over x. And the way, again, we read this would be y varies inversely as x, or y is inversely proportional to x. So again, those two statements would be telling you the same information. Joint variation is when we have more than two variables. So here we have 3 variables plus a constant k. So with joint variation, it's of the form y equals kxy. And again, since this is multiplication, the order in which it occurs does not matter. So we would read this as y varies jointly as x and y, or y is jointly proportional to x and y. So let's look at some examples. So we want to find a mathematical model for the following. A varies directly as the square of r. Y varies inversely as the square of x. And for a constant temperature, the pressure of a gas P is inversely proportional to the volume V of the gas. So, let's do the first one. We know it's direct variation, so I know it's going to be of the form y equals kx, but instead of y, I'm using a, and instead of x, I'm using r. So my equation is going to be a equals kr. That would be direct variation. However, I apologize. I wasn't paying attention. It's the square of r, so instead of a equals kr, it's going to be a equals kr squared. So the r is squared because it's the square of r. Okay, so you are going to do y varies inversely as the square of x, and for the constant temperature, the pressure P of a gas is inversely proportional to the volume of the gas. So I want you to do those two examples. Pause the video, unpause when you're ready to see the answers. Okay, so here y varies inversely as the square of x, so y equals k over x squared. Constant temperature, the pressure P of a gas is inversely proportional to the volume V of a gas, so here we have T is the constant, we have P is inversely proportional to V, so P equals T over V. If you did not get those as your answers, try to think about why that is, see if you understand why these answers are correct. Next example, neglecting air resistance, the distance an object falls varies directly as the square of the duration of the fall. An object falls a distance of 144 feet in 3 seconds. How far will it fall in 5 seconds? Okay, so first, think about what do you need to find before we can actually answer the question. Then, try to answer the question. So I want you to pause the video and try to do this. Unpause when you're ready to check. My hints are, notice that we are using direct variation, it's the square of the duration t of the fall, and s is our other variable. So now pause. Okay, so first we find our variation equation. So s equals kt squared. Then I use the given information, so 144 feet it falls in 3 seconds, to find the constant of proportionality. So I get k is 16. So now I can use that constant of proportionality to find out s, or how far it will fall, in 5 seconds. So I say s equals 16 times 5 squared, I get 400. So then I answer the problem in the context of the problem, because that shows me that I understand that my number 400 actually has meaning, and I get that it falls 400 feet in 5 seconds. Okay, so make sure we understand direct variation is y equals kx, inverse variation is y equals k over x, and joint variation is z equals kxy.